Hey class, this week's lecture will be about sustainable product design, manufacturing, and the consumer waste stream. The pages in your book are right here. We'll have a section on products and a section on recycling and waste to read this week for the quiz. I won't be able to cover electronic waste, also known as e-waste, in this particular video, but it will be a part of your discussion board, so keep that in mind. All right. So to start, let's go back a bit to the 17 to 1800s. Think about the American Industrial Revolution. So think assembly line, Ford Motor Company, mass production of consumer products, the good life at an affordable price, all that. So in thinking back to those days, if you learned about that in history class, if not, it's okay. Which of the three E's do you think is missing from the goals of the Industrial Revolution? They wanted to make products quickly, cheaply, and in large quantities. So if we were in class, I would hope somebody would say that it's the environment that's missing from this goal. We've got the economy and the equity. They wanted actually to make the good life affordable for the average person, but they did not take into account the impacts on the environment. So in your book, there's this quote from this really fascinating individual that's worth looking up on your own for fun someday, named Buckminster Fuller. He was a modern-day Leonardo da Vinci, an inventor, a thinker, scientist, and he says, it's kind of amusing, if you're in a shipwreck and all the lifeboats are gone, a piano top buoyant enough to keep you afloat that comes along makes it a fortuitous life preserver. But this is not to say that the best way to design a life preserver is in the form of a piano top. I think that we are clinging to a great many piano tops and accepting yesterday's fortuitous contrivings. So, in short, what he's trying to say is that your first idea is not always your best idea. We solved a lot of our product design problems in the moment back then based on what we had available, but now we have new knowledge that's emerged, and it's a good idea to assess, reassess, and upgrade what we're doing to solve some of these problems. So I'll get a little more specific. So sustainable design is also called design for the environment, abbreviated as DFE. It's also called eco-efficiency or life cycle design. These terms are all pretty much interchangeable, and you'll see them in the book. The goal of DFE is to minimize the product or process's negative impacts on the environment. This includes the health and safety of humans. So we are part of the environment, so we do count in this impact. Eco-efficiency is like applying the idea of efficiency, do more with less, to the environment. So it means that we want to generate more product value and usefulness per unit of resource consumed. So minimizing the footprint, but still get some of the same value. So we can look at it in this graphic where we increase the product value and decrease resource consumption. So hopefully that's fairly logical. Your book has this interesting story about a town in Denmark that provides a good example of a concept called industrial ecology. It's more or less like any other biological cycle. The products of one become the starting materials for another, but related to manufacturing and industry rather than biochemistry. So in Kalundborg, Denmark, hopefully I'm pronouncing that right, a town with a population of about 16,000 within a 2-mile radius. All these different companies and plants and things like that use one another's byproducts in a closed-loop industrial food web. For example, if you follow the arrows through the diagram, you'll see some unexpected relationships. So we'll start with this kind of interesting electrical power plants. So electrical power plants produce waste heat, and that waste heat, rather than just being let off into the air, is used in a controlled way to maintain the water temperature for a fish farm, so an aquaculture plant. And the waste from the fish is actually used as fertilizer for local farmers. So that's kind of interesting. Another relationship you'll see here is that sulfur is a byproduct of oil refining. Instead of letting that into the environment, it's actually sold to a chemical company that makes sulfuric acid, which has a lot of applications. So pretty cool example. You could read more about that in the book. Individual products have life stages as well. For the most part, it follows a diagram like this, which we've seen before. Raw materials are extracted, manufacturers make the parts and the products, which are transported to retail locations. Then the product used has some kind of end of life fate, whether it's thrown away or reused or something. So now, where does the waste go at the end of its life? There's a lot of possibilities. This waste hierarchy that we saw in a previous lecture, probably the first day, gives you some options, but we'll look at a couple more, a different way of seeing it. So waste can go to a landfill. It can go to a recycling plant. It can be composted if it's food or other organic matter that's biodegradable, so meaning that it breaks down in soil usually. It can be burned in a waste to energy incinerator, or it can be repurposed, repaired, or reused in some form of a salvage program. So donating to Goodwill could be an example of salvage, or even taking the product apart and making it into something else counts as salvage. So here's another interesting fact about our planet. So some of our waste, rather than going into some of those other locations, ends up in the Great Pacific Garbage Patch. So this is a diffuse floating island of mostly plastic waste that collects in certain parts of the world's oceans due to the current. So I'll show you this little map. There's 5 locations in the globe where the plastic waste is building up. It's shown by these white circles. And people have modeled this too to try to understand it. It's not all quite as densely packed as this. It's diffuse, so sometimes in some places it looks like an island and other times it doesn't. You can't walk on it or anything, but it's very obviously mostly plastic waste in the ocean. So that's a direct result of human activities. So there's a number of approaches to designing an eco-efficient product so we don't keep contributing to this great Pacific garbage patch. If you look at energy efficiency, that would be one option that's the most common that we see. The health and safety of materials, so we can look at making healthier materials. We can look at using less material in general. We can also look at product longevity, so this is making the product last longer, so you don't have to throw it away. You can design a product specifically for being reused, make it easier to take apart. You can also design a product that imitates nature in some way, which is called biomimicry. And then you can use a certification program like Cradle to Cradle to determine, for this program, the product must become the starting material for some other process. So I'll go through an example of each using an existing product that's out there now. So one of the things we're most familiar with is energy efficient products like the energy saving lights. So there's many alternatives to the energy wasting incandescent lamps like LEDs, CFLs. So for healthy materials, there's a lot of examples like paints that don't emit as many fumes, fabrics made with non-toxic dyes, and an example with this 2011 Ford Explorer, part of the seat cushion material is actually made from soy rather than petroleum-based foam, which is renewable and potentially less toxic according to the resource. So you can click on this link if you can copy that address into the browser, or I'll post it below. So reduction in use is almost always favorable to recycling, so we try to minimize our demand on resources. So a lot of food companies are looking at ways to have less material in their packaging. That benefits them financially as well as benefiting the environment, so it sounds like a great option. With aluminum cans, for example, engineers will work hard to figure out the minimal wall thickness of a soda can that still allows it to maintain its function of holding your soda without leaking. So it's a good option. Product longevity was a difficult one to find examples of because often so many of those products have other problems. For example, Apple computers, they're actually made of very durable materials, but you almost hate to have Apple on a list like this because their business model actually poses some significant social equity challenges. So The children's clothing manufacturer seemed like a good example. It increases the lifetime wearability of kids' clothes because they grow out of things pretty quickly. So you can actually adjust and add and remove pieces of clothes as kids grow. So it increases the wearable lifetime. In general, product longevity can be achieved by making it modular. So you can take parts off and put them back on with the same basic body form. You can make them repairable rather than the throwaway type of culture that we have. They can be upgradable, timeless, so they don't look outdated and people still want them, and durable, which is the most important thing, in my opinion. So now we'll look at design for reuse. So many companies tend to offer programs like take-back programs, like Stonyfield Farms knows that number 5 plastic, which is what their cups are made of, doesn't get recycled in a lot of towns. So they actually take responsibility for their own products by taking back the plastic and recycling them in-house. So that's pretty nice. Design for disassembly. There's this company called Herman Miller that makes a Mira chair. That's the name of the style. It's featured on the Cradle to Cradle's Waste Equals Food video. It's designed to be taken apart in 15 minutes. So a lot of the time, the cost of recycling and reusing goes way up when the product is really hard to take apart. So products that are difficult to separate are sometimes called monstrous hybrids. Products designers minimize the problem of monstrous hybrids by improving fastening technology, so avoiding glues that are toxic, hard to break apart. Hardware tends to add weight, so minimizing the number of bolts and screws used, and then sometimes making the parts snap together based on their own form rather than on external parts. So that's a pretty exciting development. And biomimicry is an interesting thing. And so although Velcro, which is the example I have chosen, may or may not be sustainable as a whole, their product does minimize the need for glue or energy-intensive sewing and attachment by imitating a feature of nature, those little sticky seed pods that get stuck to your socks when you're hiking. So it's like the hook and loop model of Velcro was inspired by those seeds. So pretty cool. And of course, Cradle to Cradle brings these ideas together using a certification program that examines the product's total life cycle. So the next video, I'll have to cut here and then move on to talk about recycling, whether or not it's worth it. So stay tuned for part 2.